classes. So this is in collaboration with Student Tribe and GDSC Lucknow. My name is Tejawant. So we have our speaker here, Diksha.
Hi everyone.
Hi, hi, Diksha.
Yeah, hello Diksha. This is Mrityunjay Vedi, Management Lead, GDSC Lucknow. And I also welcome you all to this session of predictive analysis and all by Ms. Diksha. So we'll start in 5 minutes. That's okay. Let the people join. And
Sure,
yeah,
Mrityunjay. That'll be completely fine. Thank you.
yeah. Everyone, please be patient and stick to the meeting. We will be soon be starting our session.
Can anyone confirm me if my screen is visible?
Yeah, Diksha, it's visible.
Yeah, thank you. Thank you for confirming.
For 5 minutes, let people admit like they are admitting right now. Hello.
Yeah, that's completely fine, Mrityunjay. I was just checking like if it's fine or not. I was just checking a technical thing. Yeah, thank you.
Okay.
Hi Diksha. Let's get started.
Sure. Yes. Yeah. Hi everyone. So let me present my screen. Just give me a second. Just a kind request to everyone that whenever you have any doubt, do let me know by just first introducing your by your name, so that I can get in your name and then answer your queries. Yeah. Thank you everyone. Is my screen visible?
Yes, Diksha.
Yeah, thank you. So, today's webinar is on mastering the art of predictive analysis and data spy for technical excellence. So, I'm assuming most of you are from the technical background. So, I welcome you all to an immersive journey into the realm of data-driven data decision making, where we will be unrevealing the intricacies of predictive analysis and harnessing the full potential of data for AI, Explainable Artificial Intelligence, and Blockchain from Punjab Engineering College, Chandigarh. I have 2+ years of experience in industry in R&D department, and I have 5+ years of teaching experience. I have many SCI Scopus Index journal papers along with many conference papers as well. This is my contact number if any one of you want to reach to me, and this is my Google Scholar ID so that you can actually see my research papers. So this is a little bit about myself. This is the key agenda of today's presentation, where we will be majorly covering the key concepts in data analysis, followed by introduction to predictive analysis, importance of predictive analysis in decision making, then predictive analysis process, followed by data preparation and cleaning, that's a core process, followed by EDA, that's exploratory data analysis, feature selection and engineering. Like there are some prediction analysis techniques as well that we will be covering, followed by tools and softwares that you can use for predictive analysis and some real world use cases and examples. So let's get started. Before I start with the concepts of predictive analysis, data analysis, and what sort of analysis that we have, I'll just want to ask, like, show you this Gartner hype cycle, which is a very good hype cycle we generally see across the technologies when we want to do some research, or we want to see like which technology will be the best, or which technology is generally in demand currently. So here you can see there are many phases, mainly 5 phases, where is innovation trigger, peak of inflated expectations, trough of disillusionment, then comes the scope of enlightenment, and followed by plateau of productivity. Here you can see that there are a lot of techniques here, right? But predictive analytics, that is the main talk of this particular topic, is basically in the
Hello,
plateau of. Hello, yeah.
this is Avinendra, and actually the slides are not changing.
Okay, thanks for telling that. Just give me a second. Thanks for informing that. Just now, can you please confirm? Now it's fine.
Yes, it is fine now.
Uh,
Okay,
yeah,
thank
now
you.
it's fine.
Yeah,
It's
thank you
fine.
so much for that. Thank you. So, coming again to my introduction. So, this is the introduction that I gave. This is the Google Scholar ID that I was telling you, right? Next, coming to the Gartner cycle. This is the Gartner cycle that I just mentioned. So, basically, Gartner cycle remains almost the same every year across the technologies. But the main thing is, like, the technologies keep on changing. Their positions in the Gartner cycle keep on changing. Like, here explainable AI is here. Now it may be like in this particular case. So with the time, things keep on changing in the like Gartner cycle, and it's very good when you are getting into some technology or technique. It's very good to see the Gartner hype cycle so as to understand where your technique is currently or what's the demand in the market. So suppose here you can see, you must have heard about explainable AI or natural language generation, which is the core behind large language models or generative AI currently. It was in the peak of inflated expectations some time back, right? But at the same time, it was not in the production or productivity. Now, if you see, it may be like somewhere here, where when something goes in this particular area, it is slightly adopted by industry and is actually producible, right? So here you can see the main topic of today's session is predictive analysis, right? So predictive analytics is in the plateau of productivity as of July 2021. So it was being used extensively since 2021 and was in use by the market extensively. So here you can see the Gartner cycle helps us to understand which technology has actually matured and which technology is still in its maturing phase. I hope this helps you understand why predictive analytics is a very important tool for you to get into the market of machine learning, deep learning, or any sort of analytics or data science domain or job if you want to get into. Any doubts for this particular slide? I'll be happy to answer. Okay. So I'll be moving further for the silence. Next, coming to the key concepts in data analytics. The main key concepts in data analytics are data types, descriptive versus predictive analysis, and data sources. So let's start with the data types. So data can be broadly categorized into two main types, that is structured and unstructured. Structured is basically any highly organized or typically which is stored in tables and databases. So think of it as neatly fit table which fits into rows and columns. Suppose we have a Excel spreadsheet, right? So that will be coming into structured data. Another example is a customer database where each row represents a customer and columns contain the information such as names, addresses, or purchase history. These all come under the structured data. Next, the thing that comes is unstructured data. Unstructured, on the other hand, it doesn't follow any predefined structure. It can be like more challenging to work where you have text, images, audios, or you have even videos. In these particular form, you can't find any particular structure across the data. So you have to work on it based on the unstructured techniques that we have across the uh, like uh, in the whole literature. Next, some examples of this is like social media posts, then come your customer reviews or your sensor data from your IoT devices. These all come under the unstructured data. And the main point is not only the unstructured data comes holds the useful information, even the unstructured data like social media posts as we see nowadays in Twitter as well, in Facebook as well, in Instagram as well. So these are much valuable and they require special techniques to actually extract the information from them. Any doubts for this particular thing? Difference between structured or unstructured? Any doubts? Okay. Yeah. Yeah, please continue. Okay. Next is descriptive versus predictive analytics. So there are two main approaches in the analytics that come into picture, that is predictive and descriptive analytics. So descriptive analytics primarily focuses on summarizing historical data. That is to gain insights into what actually happened, right? So it's like we actually look into the past and try to understand the past. For instance, think of a retail company, right, which is analyzing the data from the past to identify the trends, the products of the popular products, and like what were the periods in which the sales price were at the peak, right? So this is where predictive analytics help into picture, right? And it can actually help in optimizing the inventory and marketing strategies. By that we can actually understand how we can take a proper decision for a marketing sort of thing. However, on the other hand, predictive analytics is all about the informed decisions about the future events. Like based on the historical data, what we do is we try to take any decision. So it basically uses the statistical models and generally the machine learning uh, algorithms to forecast the outcomes. Suppose if I take an example, it's about a weather forecasting system. So a weather forecasting system, it analyzes the past weather data to predict the future weather conditions. So these can be like these sort of analytics can be very vital for uh, many industries like agriculture. Then comes your transportation or your disaster preparation. So these are some of the industries which can actually be benefited by predictive analysis, which is the main topic of today's session. Any doubts for these particular analysis? Though I'll be explaining it in next slide as well. Any doubts? Okay. Moving to the next thing, that is key sources. So some data sources can actually be data can be actually be collected from multiple sources, where it can be generated from sensors, it can be generated through surveys or social media or any type of thing that is digital. Or even if it's not digital, if even if we have documents that can be scanned, so anything that's in the form of information or data, we actually can take it as a data source. So it is very vital to have some sources and categorize these sources in a proper manner so that we can get the proper or related information for that particular task. Next comes the data collection. Data collection, as I told, it can be from surveys, from API keys like we get from Twitter, from Facebook, from Instagram. These are some of the main things between like data sources and data collection. Any doubt on this particular slide, you can ask me right away. I'll be waiting for a minute. Any doubts? Okay, I'll be moving forward. So, as I told, data analytics can be divided into four main types of analysis. One is descriptive, like what actually happened. Diagnostic, which means actually why did it happen. Then predictive analysis, as I have told. Next comes the prescriptive analysis. How can we make it actually happen? So these are the four main type of analysis which actually makes the core part of data analytics. So when you see a broad term as data analytics, you will be covering all of three: descriptive analysis, diagnostic analysis, predictive analysis for predictions, and for prescriptive analysis, right? Any doubts in any of the type? I'll be happy to answer.
Hello, ma'am. No doubts, but can you just press that hide button over there? It's showing some key
Uh,
concepts.
sorry. Is it fine? Is it fine now?
Yeah, it's fine.
Thank you. Yeah. Next, let's start with the main concept of today, introduction to predictive analysis. So, predictive analysis, before I talk about this theoretical concept, let me give you some example, right? So, suppose you're planning a weekend getaway, right? Suppose you're planning some a trip to any place in Jaipur, Udaipur, or anything, right? And you want to see that whether the like what should be the weather, right? Before checking anything, before checking your flights, before checking your booking your ticket for your like hotel or anything. So first, you what do you actually check? You check your what's the weather. Is it fine to go there or not? Right. So that plays a very crucial role in your decision making. So what used to be happen earlier before predictive analysis, weather forecasting was based on a limited historical data, and like whatever a meteorologist actually had the experience, it was only based on that, right? But with the advent of predictive analysis, what happens is meteorologists they now have accurate and more better decisions than they had earlier, or if I may name it as properly as predictions. Now they have a better predictions of weather, and it will help you better that now it will be raining in couple of days. It's better you don't go right now, right? So that will be a much informed decision for you to plan your weekend gateway, right? So what they do is they basically collect vast amount of historical data, and which includes temperature, humidity, what's the wind speed. These are the parameters, or what I'll be covering in future. That's a feature. So based on these features, they actually what they do is they actually do the analysis and do the predictions on the basis of that, right? So as a result, they can now provide you a better 7-day forecast, and now you can actually plan your things accordingly, right? So this is just an example like how actually the things can be done. So whether it's like finance, or which whether it comes like healthcare, manufacturing, or any other technical field, the principle of predictive analysis, it is universally applicable. You take any domain, any industry, it is applicable anywhere. So like any equipment, if you want to get into any detection in finance, any personalized content recommendation, even if you're this Amazon, it uses predictive analysis, or your Netflix, it also uses predictive analysis for doing the for actually getting the informed decisions, right? So through this particular presentation, I'll be delving into the particulars of predictive analytics and helping you to understand how you can actually use the concepts to get better into these things. Any doubts till now? Yeah, any doubts?
No, ma'am, no.
Okay. So, as I told, it basically involves the identifying the patterns and the trends so that you can anticipate the future developments, and organizations can take proactive decisions and actually get the opportunities, right? Next, moving to the next slide. What's the importance of decision making? Like, it's not just a like buzzword. It's a game changer. While we take the decisions, it's actually a game changer. I'll not say that it's just a decision making. It's actually a data driven decision making. So, in using predictive analysis, organizations actually take informed decisions so as they can use the guesswork and everything, and take a proper decision from the whole equation, right? So, if I take an example, suppose you are a retail company, right? You are planning your inventory for the holiday season. So, now taking your context from from a customer to a vendor, right? So predictive analysis can actually help forecast the customer demand by analyzing the previous historical sales data, right? So suppose I want to see like whether this Diwali, what sort of trend it was in the previous case. So what data I should take? I should take only for the previous 1 month, or shall I take for the previous 2 3 years? If anyone can help me with that, it will be helpful if we can take it like make this session interactive. I please request you to make it interactive.
Ma'am, can you please repeat the question?
The question is, suppose I give you a use case that you are a retail company, right? And you want to plan your inventory for the holiday season, for Diwali. So what, based on the historical data, as I've told you, generally take the predictive analysis decision. Now, what will be the time frame? You will be taking the time frame, the data for past 3 months or 2 months, or you will be taking the data for past 2 years.
Past 2 years.
Okay, only for that, or the past 2 or 3 months as well. Uh, is anyone answering? Will we be taking only the past 2 3 years data, or we'll be taking the past 2 3 months as well?
Ma'am, we will take 2 3 months data also.
Reason? What will be the reason behind that?
We will be using past 3 months data. It will be helpful. We can prioritize it, but we should also consider the data from past 2 to 3 years.
That's great. That's a correct answer. But what's the reason behind integrating 2 3 months data as well? If you can tell me that as well.
Ma'am, we can also take the data sample season wise, like what's like the season wise,
Correct.
like season wise for 2 years. So we'll be able to
That's
analyze
great.
that how what's the sale during this season, what's the sale
Hmm. Hmm.
during the season that is going on, and the
That's
upcoming
correct.
season. We can predict that.
You are somewhat very near to the answer. So the main reason behind taking 2 3 months is so that we can know the economic conditions of the country currently. We can know what's the trend that's going on currently. The reason behind taking the past 2 3 years data is like whether during Diwali, whether the sale is there or not, or what sort of actually the sale is there. So that's the main thing, that we take these two trends into picture when we are doing the whole analysis. Any doubts till now?
No, ma'am.
Thank you. So next is anticipating future trends. Now, as we see that predictive analysis is like just a crystal ball, which actually allows us to anticipate the future trends, right? Suppose, for example, I've just taken example of this weather forecast, right? So it basically analyzes the atmospheric conditions and predicts the weather patterns, which can be actually valuable for agriculture and emergency services, right? So that they are well prepared for the upcoming future events or weather events. Next, similar to this comes the risk management, where we can actually get to know what is the upcoming problem that can come, and we can actually take the proper informed decisions, right? Like in case of COVID, though we didn't know about the COVID beforehand, but after 1 year we got to know the previous trend, and then we were able to like correct it properly, take the risk, do the risk management, and like resolve it properly based on, and we can actually change the insurance policies as well, right? So these are some of the good examples or importance of actually predictive analysis in decision making. Next comes your resource optimization, then customer insights, competitive advantage, and cost reduction. Coming to customer insights, so in today's customer centric world, understanding your customers is actually very important, is very paramount. For example, if I take an example of Amazon, that is the e-commerce giant that we have seen, the Great Indian Diwali sale that has just come, right? So it actually employs predictive analysis to personalize product recommendations. So suppose you have bought something, right? So suppose I have seen some shoes, right? So it will, based on your search, it actually will help you understand what sort of shoes you can take based on your previous search, right? And if there is a decrease in the price, it will actually help you understand what sort of price range you see, and in that particular range, what are the good shoes that you can actually buy. That's a strategy that even uh, e-commerce giants actually use to attract the customers and to help the customers get their products in a more personalized manner, so that even customers think that it is very like user impressive, or like it's interactive by the user, right? So that's the reason they increase the sales, but also enhance the overall shopping experience. Next is competitive advantage. uh, remaining competitive in a market is actually very like challenging, where actually you have to be up to the mark, and you have to stay trending with the market, right? So predictive analysis actually offers a strategic advantage of that. So if you take an example of Netflix, right? So Netflix actually uses predictive algorithms to recommend movies, TV shows, and everything to the subscribers. Not only, like, predictive analysis is not only limited to machine learning or recommendation system. It also can be integrated with current techniques like generative AI or these things. But the core behind these things will remain as predictive analysis. That is analyzing whether the person will buy or see the things or not, and giving customer a particular suggestion whether you can actually see this or not, right? Next, cost reduction. When it comes to pricing strategies, right, predictive analysis is actually a main thing, right? Airlines, for example, they use it to optimize the ticket pricing by considering factors like demand, like time of booking, and these things. They actually increase or decrease their prices. How is it done? It is basically based on the predictive analysis, like what is the for this particular thing, what how much demand is coming, or for this particular thing, what sort of people are looking into these things, like whether it's like economic booking or a business class booking. So they increase or decrease their price. If there is no booking for a particular thing, then they actually decrease the price so as to interact the customers, right? So these are some of the importance of predictive analysis in actually decision making. Any doubts till now for these particular points? I'll be
No,
happy to
ma'am.
answer. Okay, thank you. Next, let's see the predictive analysis process. This is the predictive analysis life cycle, where you can see the whole process, right? You have identification of problem, data preparation, exploration, then transformation and selection of techniques, and then overall it goes to the evaluation. Then this is the whole process, right? Then there are some of the hot jobs that are around the market for these particular uh, like areas. Only for few steps we have specific people, right? Like we have a business analyst who actually does the data exploration or data visualization, or he actually creates the report, right? He's just for data, right? Then comes the data miner or statistician. Statistician is basically, what it does is it does the exploratory analysis, descriptive segmentation, and predictive modeling. So for these particular things, we have specific people. Those are known as data miners or statisticians. What is the basic requirement for a business analyst? You should have a good skill in basically management. You should have a good thought process where you can see how to actually see the data, how to visualize the data, how to create reports. Then you should have a good experience in tableau dashboarding and these sort of things. It's not compulsory that you should have a technical degree in like this computer science or anything. You may have a degree in physics, you may have a degree in economics. Then also, if you have good uh, technique in sorry good knowledge of data exploration or visualization, or you have good mathematical mind, you can be a good business analyst, right? Similar to this. Then your data mining or statistician. So us, who is a statistician? It's not that only a person who has a mathematical background can be a statistician. If you have good knowledge of your tools, techniques, or if you are good in stats, right? So you can be a good statistician, where you need to do a predictive modeling, right? Then comes to your IT systems or your management, right? This is a critical task, where you actually do the data preparation, you do data monitoring, deployment, and validation. This actually comes before these people. In between them comes the data scientist, which is not mentioned here. I'm really sorry for that. Data scientist is a person who actually develops the system, who develops the predictive analysis background, takes the data, does some processing, gives the output to the management team who actually monitors and deploys and validates the system, right? So this is the whole thing, right? For definitely for IT system and management, you should have some basic or good basic knowledge of skills like Python, R, then your Tableau, then your any data related things, right? Or modulated things, machine learning modulated things. If you have, if you want to get into roles like IT systems or management, you should be well versed with techniques like these, and all of these techniques I'll be talking about in couple of slides later, right? Then comes your business manager. He's somewhat of a management guy, right? Who understands business more than your IT or technical things. So all these people collectively explain him the whole insights, help him take decisions, and then based on that, he actually tells the business what's the insight, and asks the clients how they can actually leverage these insights so that they can give the, like, they can build the product in future. So this is the whole predictive analysis life cycle with various type of people involved in this particular lifestyle. Any doubts in this particular case? I'll be waiting for next 2 minutes because this is a critical slide where you can actually understand what are the job roles and what are the various like steps for predictive analysis process. Any doubts?
What's the model validation process? Can you explain that again, ma'am, please?
So, so model validation, though I haven't explained it right now, I'll be explaining it in future. But yeah, just to give you to answer your question. So model validation is basically, okay, I'll explain you in just a brief process, right? I have a data, I put it into a model, I develop a model, may it be statistically, may it be machine learning or deep learning anyway. Then training the model, I deploy it somewhere, then I validate it. Validation means whether it's working according to the uh, need of the user, whether it's giving the appropriate answers or not, right? So suppose I want to extract some information from a document, right? Or if I want to recommend a particular movie related to sports to someone, if it's giving a movie related to education to me, right? So in that particular case, that's not a valid model, right? So model validation is done internally so as to understand whether the answers or predictions are given properly or not, or I need to do some more training of the data, or sorry, training of the model. I hope that answers your question. Though I'll be explaining it in proper details for these particular steps in just next slide. Any doubts?
No, ma'am. So, one thing is that so the data scientist is responsible for creating all the models.
Right.
Okay, ma'am, got it, ma'am. Thank you.
Not just creating of models, training of first deciding the models, then training the models, and then sometimes the data scientist is also responsible for the deployment as well. So it depends on company to company, but yes, this is the main use of or work of a data scientist.
Thank you,
Any
ma'am. Got
doubts?
it. No.
Anyone has any other doubt? Yeah, please feel free to ask because I'll be waiting for next couple of minutes as well for on this particular slide, and then we can start for the next slide.
Actually, what is that full form of ROI?
Basically, this is rate of interest. Sorry, return on interest.
Okay.
Sometimes it is known as return of interest. Sometimes people say it as return on investment as well. Depends on basically what sort of technique or what sort of company you are in. So that's ROI.
Ma'am,
Any
good
other?
evening, ma'am.
Good evening.
Ma'am, I don't have any doubt regarding this slide, but regarding the analysis of rows, can I ask?
Again, can you please get back to your question? Sorry, I missed it.
Ma'am, I don't have any doubt regarding this slide, but
Hmm.
regarding the analysis of rows, can I ask now?
Analysis of?
Analysis job roles. Ma'am, can I
Yeah.
ask?
Please, please,
Ma'am,
please go.
ma'am, is it necessary to do masters or research in data science or ML to get a good job as a fresher?
No, no, no. It's like completely your wish if you want to understand things much better to do a master's. Master's is not to get job. Master's is to understand things in a more deeper way. But that can be done through your job as well, on job understanding as well, right? So if you are into a data analytics role or data analysis analytics company, that gives you more real time data, right? So in that particular case, you will understand things in a much better way than doing a master's. Masters will only help you get deeper into the things. Like suppose I have right now understood what is an SVM. If you have done machine learning, right? So if I have understood SVM, that support vector machine, in my BTech, and just this is this much that I have read till now. If I want to understand much deeper into the things, I may have to get into a master role, which or a degree, which actually helps me get into the more mathematical things of what is actually SVM. This is a very 1% or 0.1% of the things that I'm telling you, but yeah, like it's completely your wish if you want to do masters. But I'll suggest you if you are into your current year graduation years, just get into a real time job before going into masters. I hope that answers your question.
मैम another doubt, data structures and algo कितना ज़्यादा ज़रूर है AI ML या data science के?
It is. It is very much important. Though it's not directly related, but
Yeah, ma'am.
but data structures like graphs, lists, linked lists, then your sets, these make the core of your data science, right? Which data structure or algorithm to use to actually do this particular work in a more optimized way. Okay, so this is a much better way to actually understand data science. If you don't have any knowledge of data structures and analysis and algorithms, you may be able to understand data science from the upper or a broader perspective. But if you want to get proper into this data science and all it or analytics, it's better you understand data structures and algorithms first and then get into these particular understandings. I hope that answer your questions.
Yes, ma'am. Thank you, ma'am.
Yeah, welcome. Anything else? Anyone else has any doubt?
Ma'am, again one question. Ma'am,
Please, please.
data analysis role will be replaced by AI.
Data analysis roles will incorporate AI.
Ma'am, can you explain me much more better?
A replacement is where everything is automated. There is no human loop, nothing. You need no human help, right? That is replacement. Where and what I am saying is data analysis roles will incorporate AI. Means earlier the things were done by rules, by humans, by some like manual things in between. Now the things will be automated with the help of AI, right? I hope that answers your question.
Okay, ma'am. Thank you, ma'am.
You're welcome. Anyone else has any question? Just feel free to ask any question. May not be related to just this thing, but anything you have doubt till any this particular slide. Because I want to keep this webinar as interactive as possible or as informative as possible so that I can give understandings of what I have explored till now to you properly.
I believe you are not seeing the chat responses. There's a question in the chat
Yeah,
box.
actually, that's the reason I asked you so that if any one of you can help me with these one because I'm not able to see them properly. I'm on the slideshow mode. I hope you understand.
Okay, ma'am, I help you,
Thank you.
ma'am.
Yeah,
On
thank you.
there's a question. How
Hmm.
do you choose the right algorithm in predictive modeling? And what?
I'll be coming to that in just next couple of slides.
Yes, ma'am. And there's a follow-up also, like what techniques are used right now?
Just couple of slides. Yeah.
Okay, ma'am. Nothing else, ma'am.
Okay. Thank
And
you.
there's also a roadmap to how, what's the roadmap to become data analyst?
A roadmap to become a data analyst. It's better if that person can ask me that question in just couple of slides so that I'll explain that properly. And though this is also a sort of a roadmap itself, but yeah, I'll be explaining that in just couple of slides. Any other doubts?
No, ma'am.
No,
That's
ma'am,
it.
please continue.
Okay, thank you. Thank you, everyone. Next, coming to more things about data analysis process. The very first or crucial step is defining the process. So we need to clearly define the problem which we actually want to solve before we actually begin the whole process. So example of this is like suppose you are working on a problem of e-commerce, right? And the main like here the main problem will be to predict the customer churn, like how many customers are coming back after their shopping, right? So that's the problem that we define, right? Next, coming to this thing is data collection. So suppose I have this problem that is customer churn. Now I want to predict the customer churn. We definitely need the data. We need the historical data. Now we gather the customer information, transaction history, and engagement matrix. And then based on this data, we will be doing the predictive analysis. Third thing, that is data pre-processing. Generally the data that we get is in the form of raw text, or that's not completely perfect as per our requirement, as per the models that we have, right? So we have to clean the data, prepare the data properly, and enhance the quality of the data. How it is done? It is generally done by handling the missing values, handling, transforming it, cleaning it, removing the outliers. These are some of the techniques that we use to do the data pre-processing that I'll be covering in a couple of slides. But these are the basic steps for data pre-processing. Next comes the exploratory data analysis. After we have pre-processed the data, we explore the data. It actually helps us understand our data. For instance, suppose the example that I took, right? We may discover that churn is basically related to the order frequency. How much order is being, uh, like how much thing is being ordered, that is related to churn, right? This is how we do the exploratory data analysis to identify the patterns and correlations between various features. What are features? So if anyone knows about what are features, if anyone can help me understand in a e-commerce case, what are basically generally the features? Any any guesses? Any guesses? Okay. So features are generally like what are the orders, what's the date, what's the time period, right? When the order was placed, what type of product it is, whether it's a clothing, whether it's a shoe, what sort of thing it is, right? So these are the features that generally we have in the data. Based on that, we visualize and analyze the patterns and do the correlations between them, right? And next comes the feature selection and feature engineering. These are basically the main things that come into picture. We generally choose the relevant ones and we actually make create a new ones. We actually can understand the relation between various features or create a new feature. Like suppose I have a feature known as date, or what's the date of birth of a person, and I want to know the age of the person, right? A next feature that is age, though that's not in the data, but I'll create a age by creating some mathematical calculations. That is date of birth minus, or sorry, current date minus date of birth will be my age, right? That's some of the calculations that we can do to create a new feature, right? So that's the thing we can see. Either we can correlate the existing features or we can create a new feature. So this is how feature selection and feature engineering is done. Any doubts till now?
No, ma'am.
Okay, thank you. Next comes the model selection and model training, everything related to model, right? So someone asked me about model selection, right? So how do we do the model selection? We actually have various predictive modeling techniques like regression, we have classification, we have time series, all those are listed in the next couple of slides. But we we take these models based on those, based on our basically uh, requirement and the existing techniques and the uh, like requirements of those techniques. We actually select the techniques. So whether it's a classification, right? Which type of classification do I need to take? Whether it's a multi-label, it's a single label. So it all depends on your use case or what sort of output we are getting from that particular process. We will compare various models, and then we will select one particular model. It's not that if one model is suitable for your approach or for your use case, it may be helpful for the other use case as well, other similar use case as well, right? So it completely depends on what historical data you have or what type of data you have. I hope that answers the question of that particular person. If you can please help me. Yeah, whosoever has asked that question, can you please nod that is it's like clear to you?
Yes, ma'am. I think it's clear.
Okay,
True.
thank you. Next is training the model. So after selecting the model, we actually train the model. We split the data into training, testing, and then after based on that particular data, we train the predictive model on that particular training data. Once the model is trained, we have two sets: training set, testing set. Training set is used for training the model. Testing set is used to actually evaluate the model. So we adjust the model and we actually check whether based on that particular data, we are getting good accuracy or not. We are getting the results based on our requirement or not. Then we do the model evaluation. Next comes the hyperparameter tuning. Though hyperparameter tuning is a part of training model itself, but yeah. So hyperparameter is, suppose there are some things that are not constant for a particular model, right? So suppose I have a deep learning model, I have an architecture of that, but based on the historical data or use case, I actually uh, can tweak those parameters or change those parameters to actually get the proper insights from that particular data. These parameters are known as the hyperparameters. So if I give you an example, suppose I have a radio, right, or a like transmitter sort of thing, which is a static thing that is working, but I need to change the things so as to get the proper alignment with that particular station. These somehow is the analogy of hyperparameter, right? Any doubts for this particular thing?
No, ma'am.
Okay, thank you. Next is validation and testing, as we have said. Then next is deployment. Once the model is ready on the development side, we have produced the things, we have checked the things on our end. Next comes the thing to deploy it. Deployment means we use that particular model to work on the real time data. Now, earlier we were checking it on the historical data. Now we check it for the real time data. How actually it's performing according to the real time data. If it's performing good, very good. If it's not performing good for the new type of data, we need to tweak our model, change the hyperparameters, change the model. Or we generally don't change the model, we generally change the hyperparameters or train the models properly with new type of data, right? This is model monitoring and maintenance where we continuously monitor our model and maintain our model when and where required when it's not performing according to the real time data, right? Any doubts? This is the whole process of predictive analysis. Any doubts till now?
Ma'am, can we use this same predictive analysis process for fine-tuning a model like GPT Turbo to 3.5? Can we
Okay,
do this same thing?
these are two completely things, different things. Predictive analysis is where we do some prediction based on the previous data. GPT model is a generative model. We can do some predictions from generative models, but fine tuning is a concept of training the model. It's a sub concept of a process of predictive analysis. What do you mean by fine tuning? Fine tuning means where we train a model or a train an existing pre trained model to work according to our particular use case or our particular downstream task. I hope you are clear with that,
Yes, ma'am.
right? So,
Yes.
this is a sub part of training the model. But these are two completely different terms where you can't mix them. Predictive analysis is a complete process, whereas your fine tuning is a process within a process of predictive analysis process. I hope that answers your question.
Okay, ma'am. Yes, ma'am.
Yeah,
It answers my question.
thank you. Any other doubts?
No, ma'am.
Because this slide is a very important one, this and this one. So if you have understood this, I hope you are very clear with the predictive analysis. So I'll be spending my next 5 minutes for waiting if you have any doubts.
Ma'am, what will be some ethical sources of data collection? Like, can we go to Reddit and get some conversations from over there, like
You can
user responses?
definitely you can take it from your for your research, right? But it depends whether you are using it for an organization or you are using for your particular analysis. Reddit is a very good source for getting the things. Even your archive for your technical or academics data collection. You have Kaggle as well for data collection. These are various sources where you can collect the data. Even your Twitter is little on the trickier side because it takes your permission or an API to get the data. But yes, you can take all these sources to extract the data from web. That's generally known as web scraping.
Yes, ma'am. And ma'am, that would be considered ethical, right? Like, I'm not doing anything wrong with that.
No, no,
Like,
no, no,
okay,
no, no, no.
yes, ma'am.
Until unless you are doing some things without your signing in, then definitely it's a problem. Otherwise, it's completely fine.
Okay, ma'am.
Any other doubts? Yeah, I'm waiting for 5 minutes. It's completely fine. If anyone has any doubt,
There is a question in the chat box.
yeah,
Please explain hyperparameter tuning.
sure, I will. Thanks, Rick, for dictating that question to me. So, hyperparameters. So first, let me explain you what is actually a hyperparameter gain, right? Suppose you have taken a machine learning model or a deep learning model like uh, a recurrent neural network, that's an RNN, right? So RNNs have a typical structure, typical framework, which you can consider for your use, right? Now that's a structure, right? You have a data of yours. You want that particular model to perform according to learn according to your data and then perform on the real world use case, right? So if you pass the data directly and get the answer, you will be getting a completely weird answer or very like erroneous answer, right? But if you do some changes in the parameters, right? Like you do the changes in basically how the model actually learns, right? What should be the rate at which the model learns, which is known as learning rate, or what should be the epochs, how many times it should run. These are some of the epochs or sorry, hyperparameters that we take into consideration for a deep learning model, right? So these help us uh, do the training, and based on your data, it will adapt according to your data, train itself according to your data, or adjust itself according to your data, and then predict according to the training or what understanding it has got from your particular data, right? Now, once the hyperparameters are being tuned, then the training is done, then it actually basically gives the output for any new thing that is taken into consideration, like test data, right? Any real world thing that comes similar to the data that we had earlier, it will give us the output from that particular model, right? So this is the thing that is hyperparameter tuning, right? Why it is important is just to uh, ask the model to adapt according to the data that we have, learn according to that, and perform according to that particular data that we have in picture, right? So, any doubts till now, or like, did I answer your question properly?
No doubts, ma'am.
Okay, thank you. So,
Thank
let
you.
Can I
me,
ask,
yeah, please continue.
is this is recording or not? Matlab, it is recorded or not?
Uh,
Uploaded on some platform or it's just live? Because I'm late.
Anyone from the technical team, can you please help?
I'm saying that it is recording or not. It is uploaded on some platform or it's
Hi,
live.
Kushi. This is a recorded session. It will be soon.
Yeah, it is being recorded. Don't worry. Yeah, the session
Where
is being
is
recorded.
it recorded?
You'll be shared a YouTube live stream link.
Okay, okay. Thank you, thank you.
Yeah, thank you.
Ma'am, here there are some mathematical things like regression, classification, and time series. And some
Hmm.
of us are not so good in mathematics, especially this kind of mathematics, regression,
Yeah.
something like that. So, um, uh, ma'am, are these things very heavily used when like if we're doing predictive analysis, or like if we get to know a bit about regression, classification, and time series, we'll be able to um, at least get started.
Okay, that's a good question because you are being at the as I know you most of you are from the student background, right? You are from the technical colleges, right? So at your particular stage, yes, these terms are little difficult to understand, yes, but once you have to start with these things, it will be helpful if you just get the basic of mathematics behind it. But even if you don't understand it completely, it's completely fine because these have been widely implemented in various libraries, right? In Python, in R, in all those softwares or like languages that we have, these are already been integrated properly. So you just need to import that particular library and give your data and like perform it. The main thing is you need to just understand how that particular library works, how to call it, what's the what sort of data does it accept, what are the cases that you can use these techniques for, where to use a classification, where to use a regression, what's the problem with a particular type of regression, and based on that you can actually implement these particular techniques. Once you are well versed with the implementations, then you can get back to the mathematics, and then you can actually understand the mathematics in a more proper way. Now that you have understood the data, understood the way how these things work, you will be more familiar with the mathematics, and you can actually understand the mathematics in a more proper way, right? You can understand what are these variables, like y given that x, what is a x, what is y. But before that, just a suggestion, try to implement it, give the data, perform it, so that you are confident that at least I know how to implement it, then I can see the mathematics behind it. Yeah, that's a suggestion.
Okay, ma'am. Thank you so much.
Yeah,
That was very helpful.
yeah, thanks for answering your question. I'm helpful, I like happy to ask. Yeah, thank you. Anything else if you have any doubts?
No more doubts, ma'am.
There's
Thank
a
you.
question. How do we know that analysis is correct, and how do we find out the errors and troubleshoot them?
Here it comes. Validation and testing. You have test data, you have output of test data, you pass it through the model, right? Uh, you have basically test data is nothing but a part of the training data as well, right? Where you have input, where you have output, right? So input data will be basically passed to the model, trained model, and according to that you get an output. That's an predicted output, but you have an expected output as well. Then you compare both the outputs, whether the predicted output matches with the expected output or not, right? So suppose I have a historical data of last 2 3 months, right? Or if I give you a better example, if I know that I see some Netflix movies, right? For a user, I know that this person sees these particular movies, right? I have a recommendation engine in my hand, right? I give a thing that he sees this X movie. I pass it through my recommendation engine. I get many recommendations. If any one of those recommendations is according to that particular value that we have in our testing data, this means that the analysis is correct. Or testing data, if I give an analogy as, if it actually is from the movies that the person has seen in past, right? That way it's actually a correct analysis, right? So this is how we do the validation and testing. Though in the real time we actually need the human in loop to actually do the validation of the analysis, right? So that's the reason we do this monitoring and maintenance. I hope that answers your question.
Ma'am, there is one more question: the relevance of BCA student in this predictive analysis. Like they are asking for the scope of BCA students.
Anyone who has technical experience, anyone who has a zeal to learn, is has all the scope in predictive analysis, right? There is no requirement that you should be a BTech student, a BCA student. Even I have a friend who is a dental surgeon. She is a data analyst in an organization. I hope that gives you a motivation that it doesn't matter. You just have you should have a zeal to actually learn, to do some sort of a coding sort of thing, and that's it, right? Zeal to learn is the main thing in any sort of analysis process or technical these particular job roles that I have. Though this data scientist is on the more trivial side, but yeah, these roles they don't require specific degree. If you have experience, if you have good zeal, good knowledge, you can get into these roles. I hope that answers your question.
And there is one more question. The person is asking, what is big data?
Big data, nice question. Any data, big data, what do you mean by big data? It already has its answer. Big means huge, large. These synonyms that we have with big data, as I've told. So anything that can be used in the form of data has been termed as big data, means huge corpus of data or large data that we have, right? So that's big data. I hope that answers your question. So predictive analysis, data analysis, all come under the umbrella of big data or big data analytics. Any other doubts? Yeah, if technical team can help me out. Any other doubts?
Ma'am, this is not a doubt, but it's a question sort of. Uh,
Any?
Maybe a bit personal. What is your favorite model, like Google's Lambda or like OpenAI's GPT or like some other model that we don't know about because you have been working with these things quite a lot. So, uh,
Okay.
which model do you like the most, or like what's your favorite one,
Okay.
if there
So
is a favorite?
okay, thanks for asking that question. But there is there is no favorite model. It completely depends on what budget my company has, what how much does my company does want to spend on that particular thing, if they want to buy or spend on tokens or not. The second thing is what sort of accuracy I am getting. So what's my actually what's the sort of data do I have, whether it's a classification problem or a regression problem, or is it a generation problem, right? So these sort, or it's an extraction problem, right? So it completely depends on things. Or I had recently worked with a client wouldn't allow us to use large language models, right? So it, my choice of large language model then completely fails, right? So there is no particular favorite model, as I may say. But if I given a choice from open source models and open API models or open AI models, definitely if I have money to spend on that, then definitely open AI is much better. Yeah. But yeah, if I can upload the client data as well, because they have their databases for client data, and they can get access to your client data, so be aware of that as well.
Okay, ma'am. OpenAI is also easier to get started with.
Yes, yes, that's completely true.
Okay, ma'am. Thank you, ma'am.
Anything else? Okay, I'll take the other questions in a couple of minutes. For next like few minutes, I'll be covering my slides, and then we can take the rest of the questions. Yeah, thank you. Next is coming to data preparation and cleaning. Basically, data preparation and cleaning are the unsung heroes of data analysis. They form the foundation up to which the success of your analysis actually depends, right? So there are various techniques that we can use for data cleaning. One is handling missing values. So missing values can actually wreak havoc on your analysis. Consider a data set of your customer reviews, right? So where actually the reviews didn't rate actually the product in a proper manner, like the quality of the product is not good, or these manner, right? So if we don't handle the missing values properly, it can actually skew your analysis. So we might actually choose to impute the missing values with any mean or median values, or to so as to basically maintain the data integrity. So this is where we can actually handle the missing values through these particular techniques. Next comes the outlier detection or your treatment. So outliers, what are outliers? Outliers are basically the data points that deviate significantly from the norm. So there is a norm that is calculated across the data. Once that norm is calculated, we see what sort of uh, data points actually basically deviate from that particular line, right? So think about basically a sales data set, right? Where once day's sale are usually sorry, it is very different from the normal sale, right? So this basically sale is actually a outlier that we need to resolve and get the analysis. We can't be dependent on that particular outlier, and we need to change our models in such a way that this outlier doesn't affect our particular prediction. So this is how outlier detection and treatment is important, right? Next comes the data transformation. Any doubts still here for data cleaning techniques?
Ma'am, what would be an example of an outlier?
As I've just told you, in case of sales example, right? In case of sales, suppose in Diwali, on the week of Diwali, suppose I have a lots and lots of sales of this thing sweets, right? So this is basically an outlier. I can't predict that for next couple of months my prediction my sale for that particular sweet will be the same, or it will be at the highest. It will completely depend on what the previous trend, on the basic trend. So that's known as normalization of that particular data, and that particular week of Diwali will be an outlier. I hope that answers your question.
Yes, ma'am. Understood.
Yeah. Any other doubt?
No, ma'am.
Thank you. Next comes the data transformation. So generally the data comes in various formats. Like dates may be recorded in various ways across different sources. Like we can have in the form of 6/02/2023 or 6 February 2023 or uh, 6th day of February on 2023. So all these need to be brought into a particular form, and then we need to scale and transform the data accordingly. And the very common way of doing the transformation is scaling and normalization of the numerical data and encoding the categorical data. That's like suppose I say two main variable sets, hot and cold. So hot will be like encoded as 0, cold will be encoded as 1. So this is encoding, where we use the encoding to change the data in such a form that it can be easily given to our models, because models generally understand in the form of values between 0 and 1, right? So that's the reason we do the scaling and normalization for numerical data and encoding for categorical data. Currently, giving you a note that I'm talking about predictive analysis, not the uh, this generation of data, right? In that way, you can say that generation of data takes input as a whole sentence. No, I'm talking only about the predictive analysis for this particular webinar. I hope that's clear. Next comes the data quality assessment. So consider a database of customer information. Inconsistent or missing information can actually lead to customer communication errors. For example, like sending promotions to the wrong email addresses. So we need to check the data quality in a proper manner, ensuring that the customer is satisfied and we actually send the data in a proper manner, right? Or the predictions in a proper manner. So that's the reason data quality assessment is a crucial part of data preparation and cleaning, right? Next comes the data sampling. So, in machine learning specifically, balanced data are actually essential for accurate classification. For example, in fraud detection, there are more non-fraudulent transactions than the fraudulent ones, right? Or sorry, there are more number of fraudulent transactions than the non-fraudulent ones, right? So, in order to balance these things, we should have a good strategy to actually have a balanced data set that is created, right? So next comes the data splitting. We need to divide our data set in such a way that maximum of the chunk goes to the training and equivalent of the chunk goes to the validation and testing data set, right? So we should, and along with that, the it should not be the case that there is a biasness between the data. Like uh, suppose I have three classes A, B, and C. So class A's data completely goes into training, B's goes into validation, C's goes into uh, testing, right? If this happens, the model is completely biased towards training, and uh, while we do the validation and testing, we get the 0% accuracy. I hope you get to know why data splitting is much important and why data sampling is actually important while doing the splitting of the data, right? Next comes the data version control and data cleaning, right? So why data cleaning tools are required? Why? Because you can't manually do the things properly, right? So libraries like pandas or Python, sorry, pandas, which is in Python, or dplyr, which is in R, is actually very valuable for these particular things, right? So they can actually filter the data, transform the data, and manipulate the data in a proper manner. So by handling these missing values, your outliers, or your poorly predicted values, you can actually give make your data proper and give it properly for your training. Any doubts till now?
There's a question.
No, ma'am.
There's a question. There's a
Yeah.
question in the chat box. Please explain categorical variables.
Okay, that's a good question. I've given example of hot and cold. Suppose there's a temperature, right? Temperature column in the data, right? And in that particular case, the person has divided whether the temperature of that thing is a hot or cold. So if it's hot, person has written it as hot, and if it's cold, that particular value is cold, right? So if we do the data properly, like this particular thing, data transformation, we have to encode the categorical variable into 0 or 1 into like numerical values, so that it's properly given as input to the model, and the model learns it properly, right? Any doubts till now? Or if anyone has any question, you can ask that as well.
Yes, ma'am. There's one more question. How much time and resources will data cleaning require?
Time and sources. Okay, that's a good question. So, time and sources completely depend on the volume of your data or type of your data. Suppose I have more of categorical data than the numerical data. Definitely, it will take more time. Then resources is definitely your language or your libraries, or if you have more of cpu ram, if you have more ram, or if you have gpu, then gpu will definitely help more in actually doing the data cleaning process, so that it's very fast. And even if you have large amount of data, your data is cleaned in a much like faster way, though the efficiency will remain same, but it will be more faster, right? So it completely depends on your data and volume of your data, right? Or complexity of your data. These three factors are most important while deciding the question that you have, right? Any doubts if you have, like, you can ask. Yeah, if you can tell me if there is any other question.
No, ma'am. All questions done, ma'am.
Okay, thank you. Next, coming to the next slide, that is exploratory data analysis. That's the most important process while deciding what sort of data it is, what sort of trends we can get, or what are the hidden insights and patterns in our particular data, so that we can tell the customer beforehand what can be done, what can't be done, right? So, or what sort of models do we need to use in order to do the predictive analysis. So this is the sort of the most important step in predictive analysis, right? So the very first thing is the purpose, right? The purpose of EDA is actually to familiarize ourselves with the data. We need to know like what we are actually working on, and actually EDA helps us do that, right? It sets the stage for the rest of our analysis, right? Next comes the data visualization. uh, Actually, one of the most important tools in EDA is data visualization. How do we actually do the visual representations of the data, right? We can actually uncover the patterns and relationships in the data that might not be apparent from the raw data that we have, or raw numbers that we have, right? What are the tools for data visualization? The very first tool is histograms. So all of us, we would have seen those bars, or those lines that we have, those are known as histograms, right? They allow us to see the distribution of a single variable, right? For example, let's say you are actually analyzing a data set of customer ages, right? A histogram can actually show us whether the age distribution is skewed towards a particular age group, or whether a person, like a single age group buys that, or it's like distributed across the whole age pattern, right? So this is how histograms can actually help us. Next is box plots. Box plots actually give us a sense of the data spread, how actually the data is spread, showing us the majority of the data of the range where actually our data lies, right? They are actually very good in identifying the outliers, whether we have some outlier in our data or not, right? So for example, in a sales data set, right? So in a sales data set, a box plot can actually help us spot the products with exceptionally high or exceptionally low figures. A very good example of this is if someone of you would have done some stock trading also, right? In intraday trading or in a trading, we see those boxes above line, below that line. It is similar to a box plot, right? Where we have values within that block box, above that box, below that box. So those above box, below box are known as the outliers, right? Next comes the scatter plots. Scatter plots actually reveal the relationships between two variables. So example, like we have a information about the student, how many hours the student actually studies and what are their exam scores, right? So a scatter plot can actually help us whether there is a correlation between them or not, right? So this is how actually a scatter plot helps, right? Next comes the heat maps. Heat maps are actually very excellent while visualizing the relationship between multiple variables. We have a very good area of research in data science or data analysis, that is explainable artificial intelligence, which actually my PhD revolves around. So in that particular case, heat maps helped us a lot to understand the reason behind the prediction of a particular model, right? So heat maps are actually important in stock market analysis as well, where we can analyze the stock prices and understand where the stock is actually going, right? Any doubts till now?
No.
Okay, thank you. Next come the descriptive analytics. Moving to the statistics. They basically exploratory data analytics. They actually provide a summary of the data central tendencies and variability. So what comes in the descriptive statistics is your mean, median, and mode. Then comes your variance and standard deviation. Then comes your skewness and kurtosis, where skewness tells us the where, like, if the data is actually skewed in a particular direction, and kurtosis measures the like tailedness, where like if there is a tail that is being formed in a particular data set, right? So this is how EDA can help us, right? Next comes the correlation analysis. So these are some of the techniques that we generally use for EDA, right? So correlation analysis helps us understand the relationships between the different variables, right? So one of the ways, your Pearson's correlation coefficient. Next comes your visualizing correlations. So in conclusion, if I may tell you, exploratory data analysis are just a like starting point of our data analysis. It actually equips us with the tools to actually make informed decisions about data cleaning, feature selection, and engineering, and actually choose the models that we have, and we can actually understand the model accordingly, right? So this is how EDA can help in the whole process of data analysis. Any doubts till now? Or I can go on further, like for the next processes. Any doubts?
Ma'am, most of the programming languages have libraries for doing for generating histograms or box plots or heat maps, getting the
Right,
median mode, right?
right, that's correct.
Okay, ma'am.
Yeah,
Ma'am,
Python, R, all those have tools and techniques to actually do the data visualization. Even many UI based systems, they have EDA tools.
okay, ma'am.
Yeah. Any other question do you have?
Ma'am, so we don't have to implement from the starting, like the entire thing. We don't have to
Writing a
implement.
function of a histogram and then implementing it, right? Yeah,
Ye-
that's your question?
Yes, ma'am.
No.
We can just directly use the
Right,
function provided by library.
right. Though you should know the understanding, have a good understanding of that, but it's not required to implement it, right?
Okay. Thank you,
Yeah.
ma'am.
Welcome. Next comes feature selection and engineering. So feature selection is the process of actually cherry picking relevant attributes or features for our basically analysis. This step is actually crucial because it reduces the dimensionality of our data set, making it more manageable and improve our model performance. If I take an example and like walk you through that. So basically, predicting the customer churn, right? So imagine we are working on a data set that contains customer information such as age, then your usage patterns, then the number of complaints. Feature selection actually selects the useful information that for that particular output variable and help us understand the whole things, right? So this is how feature selection helps. Next comes the feature engineering. Feature engineering, as I've just told, it's like changing or transforming the existing features and creating a new feature which can be helpful for getting the output of a value. Suppose I want to predict how many customers will come back or not, or whether a customer will come back or not, and I have a feature uh, like if he has bought that particular product or not. Yes, no, yes, no. So yes, no will won't be a useful feature for my particular model, but 1010 will be. So that's feature engineering, where I'm creating a new feature, or I'm changing, transforming the existing one, right? So this is how feature engineering help us, right? Any doubts till now? What's the difference between feature selection or feature engineering? Any doubts? Okay. So it's very important to understand that actually feature selection and feature engineering, they both go hand in hand, where feature selection makes sure that you are working with the most important or relevant features that we require, and feature engineering actually polishes the features that we require to its full potential, right? However, there are few challenges that we need to understand while working with feature selection and feature engineering. The very first is, how do we select the right feature, right? So in order to go with feature selection, we have to select a proper feature that is relevant to our particular use case, right? Next, suppose I want to see uh, whether the person will be able to buy a particular product. In that particular case, for me, it will be like what is the expenditure of that person, how much salary of that this person take, or what's the age of that person, right? I'm not interested in seeing what sort of movies does he see, or what sort of TV shows he sees, right? So selecting the right feature is the uttermost thing while doing the feature selection and feature engineering. Next, avoiding overfitting. Fitting, we should not take or use those features which actually take our model to overfitting. Overfitting means getting more accurate results and getting towards only one type of feature, while giving less accuracy for a new type of feature, right? That's overfitting, right? Next, coming to balancing and balancing interpretability and predictive power, there is a complete challenge of this particular value as well. Next like these are the main things that come into picture to illustrate how actually feature selection and engineering works. Is let's go back to our customer churn prediction. So suppose you decided to add a new feature representing the number of customer service calls made by each client, right? This is where feature engineering helps us, right? So how do we use these is the main thing that we should take into consideration while doing the predictive analysis. So in a whole, feature selection and engineering are essential steps in the data analysis process. They help us create concise, informative, and valuable information for our particular use case, and further help the model to actually get uh, proper training data, right? And get proper information from that particular data, right? So any doubts still here? Yeah. Any doubts? or any questions in the chat?
No, ma'am.
Okay, thank you. Next is predictive analytics techniques. I'll be spending major of my next half an hour on these particular techniques because these are main techniques that are being used for predictive analytics, and using these you can decide which type of model that you actually need to use. First is regression analysis. Regression analysis is a fundamental technique used to predict a continuous outcome, right? For instance, in finance we employ a linear regression to actually predict stock market prices based on historical data, right? Similarly, logistic regression actually it helps us to uh, find the application in predicting the binary outcomes, whether it's a customer churn or not. Sometimes logistic regression also comes in the uh, like classification as well, but regression analysis helps us to understand the the values of a continuous outcome, right? Any doubts till now? I'll be picking some of them and explaining them, and then you can ask the doubts related to that. Okay. Next come the decision trees. Decision trees are basically versatile tools that actually help us make decisions by creating a tree-like structures of your choices, right? In healthcare, a decision tree can be used to predict the patient outcomes. Suppose whether a person is like based on the historical data, whether the person will be having a particular disease or not. So decision trees help us create a tree like structure and classify the that particular value, right? So basically based on that you can decide it. One main reason of using decision tree is you can actually get back to the reason behind the whole like prediction, like what are the features that contributed towards that particular prediction. So explainable artificial intelligence has a major use of decision trees, where decision trees can actually help us understand which features were taken into consideration while making that particular decision. Like similar to that comes the random forest and your support vector machines, which are very commonly known as ensemble methods, which are like they actually help us predict the customer preferences and like segment the markets. So random forests are mainly the various trees that are combined into a forest, right? So these are also helpful for explainable artificial intelligence. Then your support vector machines are also classification techniques. And then your k nearest neighbors, they are primarily used for recommendation systems, where you can they can actually help us understand the customer behavior and basically recommend the proper values according to customers behavior, right? Any doubts till now?
Sorry, ma'am, but can you explain linear? Can you explain the difference between linear regression and logistic regression once more?
Sure. So linear regression is primarily used for your like regression, where you want to like get a continuous value of what sort of like generally what is used in linear regression is given a particular value or a feature, what will be the next value of that particular feature, right? So or that particular trend. So in order to understand that, we use linear regression. However, logistic regression is generally used in your classification, where I want to understand whether the customer will come back in the to that particular like to that particular process or not. So in that particular case, in customer churn, we generally use logistic regression. I hope that answers your question.
Yes, ma'am. Understood.
Yeah, thank you. Or a good example of linear regression can be your stock markets as well, stock prices as well, where you get the stock prices based on the previous data. Any other doubts? Yeah, anyone has any other doubts?
Ma'am, K-nearest neighbors are also used to generate decisions based
Right,
on a particular feature.
right.
Okay.
Ma'am,
Like,
which technique is used in cricket for data analysis?
basically, if you go to the base behind that, what do we need to do in cricket? We need to understand, based on the previous history, whether the person will be able to make a particular, like two main things are there: whether the person will be selected in a particular team or not. That's a classification thing. Then another use case can be whether the person, like what sort of runs, how many runs the person will make in this particular match, right? So based on the various factors, like whether where the person is making, is playing, right? What sort of environment it is, what sort of like environment he has already played on, all these things or factors will actually play a great role in getting whether the person, how much basically score the person will make in the upcoming, basically this thing, in the upcoming match, right? So this is a regression task. So you can use a regression technique to predict this particular value. So it completely depends on your use case in cricket as well, or in any sport. Based on that, you can like use any of these techniques or other techniques that I'm going to refer in the further slides. Any other doubts? Okay.
No, ma'am.
Yeah.
Ma'am, it's already 6 for 38, I guess. So if you can wrap up as soon as possible, please.
Yeah, I think we have 20 minutes more.
Yeah,
Yeah.
please.
Yeah, I have made according to that only. Yeah. Thank you
Yeah,
for that as
please.
well. Yeah.
Okay.
Next comes your neural networks and deep learning. These are the main things that are being used in predictive analysis or state of the art techniques that are being used currently, right? Next comes your time series analysis, ARIMA clustering. These are mainly used for your uh, like analysis based on your particular data, right? So anything that you need to choose will completely depend on your use case first and your data. So in clustering, if you don't have any labels corresponding to your data in your historical data, then you will be using clustering, whether it's k-means, hierarchical, or principal component analysis. It completely depends on your historical data, whether it's labeled or unlabeled, that you use, that you choose a particular predictive analysis technique. And then again, you can use a ensemble method, you can use NLP techniques, anomaly detection technique, or if you have a use case of your like Netflix or recommendation, or your Amazon reviews, right? So you can use a collaborative filtering or your content based filtering, or ensemble of both, right? So to do the recommendations, then your text mining and sentiment analysis can be done, or your reinforcement learning, where you learn from the feedbacks given by the user on a continuous manner. So these are the various techniques that you can use, or models you can use based on your data and your use case, right? I hope that answers the question to a person who has asked about what are the models that we can use. Okay. Next comes to the final or second final thing, that is the tools and softwares that we can primarily use. So the main tool that is being used in predictive analysis and data analysis is Python. Python is basically a powerhouse in data analysis. It is known to have a lot of extensive libraries and a lot of community support that we have. We have various enriched libraries like NumPy, Pandas, or Matplotlib for data manipulation and data visualization, if I may say. Anything you name it, you can have a library of Python. Suppose I'm writing a software, or I'm doing some research on a new thing, right? I can give I can give that particular software to Python to integrate it in their particular uh, this library, but it is known as open source. Because Python is open source, I can add my library into Python and anyone can actually use it basically. So this is how Python is actually has a lot of enriched ecosystem for data science users, and they can actually use it directly without doing the previous mathematical functions, or without actually writing all the functions for using a particular thing, right? I hope that answers that particular person who asked me about how actually that we need to write a particular function or need to understand mathematics behind or not. Yeah.
Yes, ma'am.
Thank you. Next is R. R is not that much used as extensively used as Python, but yes, it has a lot of features that Python has, right? And it is enriched for statistical functions. Many uh, tools and techniques are being used in R, which are not, which doesn't have that much enriched functionalities as or as Python has, right? So R is much enriched in statistical and data analyst uh, roles or functions that even Python doesn't help us with, right? It is very much favoritized by people who are statisticians or who are actually researchers, right? So with comprehensive libraries for statistical modeling, we can use R for conducting advanced regression analysis on even medical research data, right? Next comes the Jupyter notebooks. These actually help us provide interactive computing environments that are actually very helpful for data exploration. Anything that you need to do, you can actually start doing on Jupyter Notebook with any of these languages, whether it's R or Python. You can use Jupyter Notebooks for these things. Next comes your SQL. SQL is basically a language for managing and retrieving values from relational databases. You can query the databases using SQL, right? You can use SQL queries to retrieve and manipulate data in the databases. It is actually helpful in tasks like customer segmentation in retail business, right? Next come Tableau. Tableau is basically a powerful data visualization tool which is user friendly and allows us to create interactive dashboards. Right. Next comes your Power BI. Power BI is a business analytics service which offers us data visualization, dashboarding, and reporting capabilities. I hope if anyone remembers, any business analyst mainly requires SQL, Tableau, and Power BI as one of the core techniques that he needs to know to do their work, right? Next comes scikit-learn, TensorFlow, Apache Spark. These are mainly the libraries for your machine learning and your analysis. Scikit-learn, TensorFlow, and PyTorch are mainly used for machine learning and deep learning capabilities. Then your Apache Spark is mainly used for distributed data processing techniques, where we can uh, handle the big data and real-time data, right? Next is Excel. Most of us are very familiar with this tool, and though it has limited capabilities, but with the advent of your generative AI, we can actually have complex capabilities to be done on Excel as well, right? Next comes your MATLAB. That is a very good tool for data analysis and visualization, and it has a high level programming language as well. Next is a SAS. SAS is basically an analytics and data business intelligence tool, which is very widely used in industries which require strong data analysis and representation. Similar to this is Hadoop, Nime, and Alteryx, which are very famously used for data storage, data analysis, and data preparation or workflow automation across the industries, so that industries can do data analysis in a proper manner, right? So these are majorly the tools and software that we generally use. Next comes your healthcare and analytics. Before I move to the real world applications, I'll be waiting for 2 minutes for anyone who needs to ask any question for tools and softwares.
Is there a preference in the industry over Tableau or Power BI?
Uh, it depends. Like if it depends on what sort of permissions the company has, or what sort of like licenses the company has, right? It completely depends on company's choice. If you are more experienced in Tableau, you can move to Power BI very easily, and vice versa. So these are interchangeable, like softwares that you can, or platforms that you can use and you can get skills in, right? I hope that
Yes,
answers your question.
yes, ma'am.
Yeah.
And there are some questions in the chat box. Like, if someone is trying to get into this field of data analytics, what sort of projects should he be holding?
A project completely shows what sort of skills do you have, right? So if you want to get into data analysis, it's better you showcase your skills as using SQL, uh, getting the data from Excel in a proper manner, then doing some machine customer churn or recommendation system, sort of a building such a system using Python or R, choose any one language, and then doing some analysis on the top of that, show some charts in a proper manner, and show what sort of insights that you have, right, from that particular data. This is how you can choose a project, and this is how you can, like, it doesn't completely depend on how you actually write it in the resume. It completely depends on how you like show it to your interviewer, how you have done it, what sort of data set you have used, how you have done the data cleaning and data pre-processing, how you have done the exploratory data analysis, what sort of analysis did you do, how do you check the things, how do you decide the model. This is all depends on how you actually use your uh, knowledge for predictive analysis and do the things in the company for the real time data. I hope that answers your question.
Yes, ma'am. And there's one more question. What are the advantages of using Python over other programming languages for data analytics?
That's a good question. So as I've told you, Python is an open source language, right? It has a lot of libraries. You name a library, or you name a research that is being going on, you and you have that library in Python. You need not implement the things from scratch, like for GPT, right? The main like core behind that, or architecture behind that, was transformer, right? Python now has a direct function to call the transformer. You need not write it from scratch and implement it. You just call transformers from transformers, and then you can implement anything that is using transformer, right? So that's the beauty of using Python. And the main thing is customer or like people who are actually contributing to the language. It is huge. Anyone who is like doing some research is contributing their particular library onto the Python. The very first thought that they have is, I should have my library or work onto Python, right? So this is how Python is more useful than any other language. But it completely depends. If you are a statistician, then R will also help you give more visualization in a more better manner. But it completely depends. I hope that answers your question. Okay, I'll be taking the rest of the questions once I'll be completing my slides. Just give me 5 minutes more. Yeah. Okay. Let's delve into the fascinating real world applications of predictive analysis and data analysis. We have seen a lot of theoretical example, theoretical work, theoretical things that we could see for predictive analysis and so. But let's see what are the real world use cases that are across a lot of industries. First is first is healthcare analytics. So in the realm of healthcare, predictive analysis actually plays a pivotal role. Imagine a scenario where we can actually predict the patient diagnosis and treatment outcomes based on some of the factors. This will be very helpful where we can actually use the historical data to predict whether the person has a particular disease or not. Or we can analyze some of the images based reports like MRIs or X-rays and then give the outcome. Or we can monitor the disease outbreak. In that particular case, healthcare analytics help us a lot in actually predicting the values or predicting the diseases for a particular person, right? Next come the financial forecasting. Predictive analysis is actually a game changer in terms of finance, right? Suppose I want to predict some stock prices, right? So analyzing a credit score or detecting a fraud. In that particular case, data analysis is actually at the forefront. Uh, like if I take an example of stock market prediction can help us uh, like use predictive analysis by analyzing the historical data and give the values of what can be the upcoming stock prices and how we can actually use it, right? Next comes your credit risk assessment or fraud detection or your portfolio optimization. Any application that you have across the market in financial forecasting, uh, predictive analysis can be of a lot of help and can help us in like doing each and every prediction that we have across the market, right? Next comes the manufacturing quality control. uh, Maintaining product quality and minimizing downtime are actually the paramount in manufacturing, right? Predictive analysis can help us a lot rescuing these things. And basically predictive analysis can help us do the quality control in a proper manner, right? Suppose we have a manufacturing plant, right, that actually uses a predictive analysis to monitor the quality of its products. By analyzing the data from the sensors and the cameras, the system can actually instantly detect the defects and trigger the corrective actions. This is how predictive analysis can help us a lot in finance forecasting. Any other doubts? Any doubts if you have in this particular case? Okay, coming to the next applications, that is retail and e-commerce. Many retailers like Amazon, they actually utilize predictive analysis extensively for demand forecasting and personalization. They can predict like for what actually the products you might be interested in and offer them in a more like proper manner so that you can actually get the results and you can actually buy them. This ensures that the person is having a good experience uh, and the retailer can actually get the more like demand of that particular product. Next comes the energy and utilities. In the energy sector, predictive analysis helps in energy consumption, prediction, and grid optimization. For example, we have a company, right, that uses predictive analysis for demand for forecasting the electricity demand, right? This will help them to efficiently allocate the resources, reduce waste, and contribute to a more sustainable energy grid, right? Next come the transportation and logistics. Various companies like Uber or your FedEx, they primarily rely on predictive analysis, right? For route optimization. They use the real time data to actually find the quickest route and the cost effective route, right? Next comes your telecommunication, human resources and talent management, and your social media marketing. These all are being uh, a good applications for predictive analysis and where predictive analysts can be employed for actually doing the like decision making, right? So these are the major applications. Next, coming to the additional resources, you can like refer to these books which are a good like resources for understanding predictive analysis. There are some websites where you can use for data and analytics and a lot of like existing techniques and tools that are coming daily into the market. That is Kaggle, Analytics Vidya, and KD Nuggets. Then courses which can be helpful are Coursera, edX, and Udemy. So this comes to the final thing. And thank you all for being so patient across the whole webinar. And that was a completely good session that I had. And any doubts, if you can if you have, like, you can take it. Yeah, thank you. Yeah, I'm happy to answer if any questions or doubts you have.
There's a question in the chat box.
Hmm.
As a business analyst, how one can develop storytelling skills?
Can you please come again?
As a business analyst, how one
Mhm.
can develop storytelling skills?
As a business analyst, how one can develop storytelling techniques. Okay, so there are many case studies or like things that are there. So if you want to get into business analysis, right, so what you need to do is you need to take a course on case studies and read a lot of case studies. Take any case study example, see what are the answers that people have given across the like in Google search or in these blogs, what people have answers. Then what I have seen across the answers is what people do is they start with a example, right? Suppose I want to, the main question that comes is what is like how can you predict the uh, the upcoming sales for a particular for a particular tire that I have, right? Or what can be the next sale in the upcoming things? How can I start it with? What I can do is I can actually guess a number. That's generally known as guesstimates. I can guess a number. I can then basically use my skills to actually take various cases across the things, and then I can actually, based on those cases, I can drill down the whole uh, uh, numbers and then give a particular answer for that particular question, right? So this is how I can answer the guesstimate. Like start with the very basics, take a number, see all the cases that are prevalent across that particular use case, and then give a final output, right? Yeah, I hope that answers your question. Anyone has any other doubt? Yeah, I'll be happy to share you my LinkedIn as well. Just give me a second. Is my screen visible?
Yes, ma'am, your screen is visible.
Thank you. So this is my LinkedIn. If anyone wants to visit and connect with me, I'll be happy to help you. And any questions if you have, you can ask me there as well. Any other doubts or questions if you have anything related to like predictive analysis or future or anything?
In India, is this predictive analysis and data analytics is going to increase or like?
Definitely. Like
And
like anywhere you see any thing you see, like any industry, it has a lot of data with any industry you see. So if you have data, you have data analysis. You require data analyst and predictive analysis.
and there are many foreign companies also that are hiring, outsourcing Indian talent in this specific area.
That completely your choice. Like if you want to go towards MNCs, you want to go towards like startup, it's completely your choice. Any other things?
Ma'am, how much time and effort would it take for a beginner to like uh, get to be confident enough like you in this field? Like, uh, I'm not able to frame this, but like
No, I'm
to
getting your thing.
know the skills
Yeah.
confidently.
So it completely like depends because you are just a beginner, right? So like it's completely, as I said, like it's your zeal, how you actually see things, right? How much consistent you are in this particular, or like what's your learning strategy, right? So if you are go step by step and do it properly, then it completely, it's not a big thing, right? You can do it properly and you can go through it, right?
And it also doesn't matter where you come from, like if you're a BCA student or a
No,
BTech.
no, 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 no. As I've already told you,
Ma'am.
I have a friend of mine who is in this dental science. She is a data analyst with an organization.
Yes, ma'am, that was very inspiring.
Any other doubts or questions if you have? If anyone has.
Ma'am, how can one contribute to open source projects through data analysis?
Okay, that's a good question. So, open source means anyone can contribute, right? So, you suppose you see a research paper which doesn't have a library currently in Python, right? So, you create that particular folder or all the files that you have related to that particular paper or research paper, and then you actually give it as a as a project to Python, right? Python people will actually analyze that, and then they will actually add it as a library to your to Python. Then anyone can actually call your library and use it directly based on the things that you have done, right? I hope that answers your question.
Yes, ma'am.
Any other doubts? Okay. Uh, yeah, Mrityunjay, I think we are like done for the session for the webinar for now. Yeah. Thank you everyone for being patient, and I had a great session with you. Thank you.
Thank you so much, ma'am. Thank you, ma'am. Thank you, ma'am, for having with us, giving us your prestigious time, and thank you all present here. So, this, are we having the HR here?